Okay, the first example we're going to look at is pricing decision at a company. So Madison Company manufactures and retails a certain product. The cost of production is $50 and the company wants to set a price at which the company can make the maximum amount of profit. Now, how do you set the price? Well, the price will have an effect on demand. If you increase price, the demand will go down. If you decrease price, the demand will go up. So how do we set the price? So first let's look at the profit function. Okay, so if P is the price that the Madison wants to charge, then 50 being the cost of manufacturing the product, P minus 50 will be the price per unit. Now the total profit will be then how many units we can sell, what is the demand. So P minus 50 times D will give you the profit. And as I said, the problem is P and D are related. Okay, the value of D is determined by the price we charge. So how do we come up with that relationship between P and D? And we will look at two possibilities. So one possibility is that the demand is a linear demand, which means the demand is equal to A minus B times P, where B is the number of units of demand that will go down for each additional dollar of price. So this is a linear function. Now you can also have a constant elasticity function, which means that if you increase the price by a certain percentage, then the demand will go down or change by that percentage. So it is based on percentages rather than amount. And that relationship is given by this function. So demand is equal to a constant A times price to the power of B. So to determine the values of A and B, we need at least 2 points. One price, and at that price what the demand is, okay, from past data, and then one more point with price and demand. So we need 2 points at least. Okay, if you have more points, then you'll be able to fit a more accurate line through the point. So at least 2 points are needed. So now let's go to the Excel file and then we'll complete the problem. Okay, here we are given 2 points on the demand curve. So we have price and demand, and from past records this is given. This is input. So let's do that. And we want to try two different functions, a linear demand function and constant elasticity function. So we can now plot these 2 points, okay, with demand on the y-axis, price on the x-axis. Okay, we'll first plot demand. Okay, we'll go to scatter plot, select that. Now we need to add the x-axis. So go to select data. Okay, here is demand. So edit that and insert the x range there. Okay, click OK and OK. So we don't need a legend, so we'll get rid of the legend. Okay, so now we want to fit a constant straight line, linear demand, and for that we can go to, there are many different ways in which we can get this. We can go, one way is go to layout and fit a trend line through those 2 points. And I want to select more trend options, and that way I can also generate the function, the B sub 0 and B sub 1 values. So here we want to select linear, and here we'll select display equation on chart. Okay, so that way the equation is displayed. And let's also put some titles. So vertical axis is demand and x-axis is price per unit. Okay, so let's put that here. Okay, let's keep it there. So that's and we will say linear demand function. Okay. We want to make sure that we have sufficient decimal places, because we don't know whether it is 10 or 10.56 or 10.57634 or whatever. So to increase the decimal places, select the box, right click, and then you have to go to Format Trend Line Label. Okay. Go there and you'll select number. Okay. And here is where you can increase the decimal places. I'll put 5 decimal places. In linear function, it probably doesn't matter. 2 decimal places would be fine. But when you go to constant elasticity or exponential function, you do need several, at least five, maybe more. Okay. Now let's move that down here. And you see that the decimal places are all 0. So here 1100 is your B sub 0 and minus 10 is B sub 1. So let's go to the linear tab and enter those values there. 1100 is intercept and minus 10 is the slope. So we'll come to this sheet in just a little bit. So we have one more function, which is the constant elasticity demand function. For that, once again, we have to draw another plot. Okay, go to scatter plot. Okay, let's move this down. Remove the legend. Now let's add the x-axis. So for demand, edit and include the x-axis values. You don't forget that. Okay. Now click OK. Now let's change the titles. This is constant elasticity demand, and horizontal axis is price per unit. Vertical axis is demand. Okay, so now we want a power trend line. So go to more trend options. Okay, power, then display equations on chart. So now we have the function, and we want to make sure that this is formatted properly. We don't want scientific format, and we do want more than just 3 decimal places. So right click, trend line labels. Now select number and put 5. Okay, so now we have with 5 decimal places A and B. So now we highlight the A part very carefully without making sure that all decimal places are covered. Then Control C. Now this is constant elasticity demand. So we'll go to this tab and enter it here. Okay. So increase the column width like that. Then you'll have the constant part. So let's go back and now very carefully highlight the exponent. Copy that and click there. So now we have to erase the formatting. So for that you go to clear and clear formats. Okay, so now we have the constant and the elasticity part. So we have the linear demand function and constant elasticity demand function, and our task is to determine the price at which we will have maximum profit in each of these 2 cases.